All right, so here we are at chapter 1, finally. Here it is November, and we're doing chapter 1. All right, let's go right to an example. I'm not even going to do any talking about it. Let's go right to the example. This is called linear equations. This is a word we haven't used yet so far in that whole review chapter. I don't think we've actually solved for x at all, but that's what this is, linear equations. Linear, what word is in linear? Line, okay. So they're straight lines, not curves or anything like that. We're just going to solve for x or y or a or b or c or whatever they ask you to solve for. And equations, we're going to have an equal sign. Okay, we have something equal to something else, and we're going to solve for x, basically. Okay, that's basically what we're going to do in here. So let's take a look at example 1. All right, and these all say to solve. Now, most of the time it's x. I think all of these it's x, but they could ask you to solve for any letter. I'm taking a look. Pretty much everything's solving for x. So here we go. This should be very familiar to you. This is Algebra 1 stuff, even pre-algebra. You learn this in pre-algebra. Go ahead and do that. I'll give you 20 seconds. You should be able to do this in 20 seconds. Ready? Go. Do it. Write in your notes. Solve for x. Might be able to do it in your head. 3x minus 5 equals 4. Who got an answer? Billy, what'd you get? There you go. All right, as easy as that. So what were the steps to this? Well, first of all, here's a couple things that I'll say. Every math teacher teaches things a little bit differently, but they basically do it the same way. They teach it the same way because everybody says, oh, they do it so different. Nah, their terminology might be a little different, but really solving the problem, every math teacher solves this problem the same exact way. All right, but their terminology may be a little different. So what I do is I look to see what I'm solving for. I'm solving for x. A couple things are going on with this x. First of all, this 3 is being multiplied by the x, and then the 5 is being subtracted from this 3x. Everybody see that? First thing I want to do when I solve for x is get rid of what's being added or subtracted first. Everybody hear that? Get rid of what's being added or subtracted to that x first. Don't get rid of the 3 right away because it's not being added or subtracted. It's being multiplied. Get rid of what's being added or subtracted first. Okay, it's kind of like the opposite of please excuse my dear Aunt Sally. Remember that? You do parentheses first, multiplication next, addition and subtraction last. Well, when we're going the other way, we're trying to solve for x. What I try to do is get rid of the stuff that's being added or subtracted first, then you can get rid of the stuff that's being multiplied. So the 5 is being subtracted. We have to get rid of that. How do we get rid of something that's being subtracted? How can I get it to cancel out? Or some books say undo each other. What do you think, Andrew? Exactly. So I do the opposite, okay? What's the opposite of subtraction? It's addition. That's how I'm going to get rid of it, all right? The reason that I add it is because I get rid of that minus 5 over here on the left-hand side. Now, remember back when you did this, again, different teachers say different things, but I always say whatever you do at the left side, you do to the what? To the right side. I had a math teacher when I was in high school. He kind of went like King James biblical version on it. He said, whatsoever thy hand doeth on the left, do also on the right. Okay, he kind of wanted to make it sound kind of fancy and, like scriptural or something, I guess. I don't know. Put all those King James words in there. But basically, whatever you do, here's the NIV version, right? Whatever you do on the left, you do on the right. That's basically what we're doing. So if you add a 5 on the left-hand side, you can do that, but you got to do the same thing on the right-hand side. It balances it out. Okay, so if I add something to this side, how do I keep them equal to each other? I got to keep them balanced, so I have to add it to the other side, right? You ever get on a, what's that thing where one person sits on the end and the other person, seesaw, right? A little seesaw thing, you ever do that? Probably not too much anymore because they got rid of them all in the playgrounds because it's apparently not safe, but man, we used to, you ever get on a seesaw? Anybody do that? Right? And you're at the bottom, your friend's at the top, so if you're a good friend, what do you usually do? Jump off, right? And let the other kid fall to the ground, That's what we always did. I was on both ends of that. So you got to keep it balanced though, all right? You have to have the same weight on one side, same weight on the other side, and then you'll be balanced. That's what this is right here. All right, enough talk of that. So what happens here? Minus 5 plus 5. They cancel out, right? Or they add up to 0 is what they're really doing. So I bring everything down. I didn't do anything really to that 3x. So I keep it there. 4 plus 5 is 9. Now, what's happening to the x this time? It's not being added or subtracted. It's being what? Well, it's being multiplied by 3, right? But how do you get rid of the multiplication? Now you can say it. Now you divide, okay? So it was being multiplied. How do you get rid of it? What's the opposite of multiplication? It's division. So we divide this side by 3. Whatever you do to the left side, you do to the right side. So the 3's cancel out. Now, do the 3's cancel out for the same reason as the 5's canceled out? Because we use that word cancel out a lot, okay? And it's okay. I don't mind it. I use it a lot myself. But you have to realize why they cancel out. They cancel out here because they added up to 0. Why do they cancel out here? Because you have a 3 over 3. What's 3 over 3? It's 1. Can I multiply anything by 1? Sure. What? Of course I can. I can multiply anything by 1. It doesn't change the value of it, right? So I'm allowed to do that. You understand mathematically why you can do that? All right? So that's the reason. So that's why they cancel out. I just think it's important to point that out because some math teachers just say cancel for everything, but they don't really tell you like why they cancel. What's the reasoning for it? So they cancel out, divide each other out. Okay, it's a 1 times x is x, and then 9 divided by 3 is 3, and that's it. If you wanted to, we're not going to, but if you wanted to, you could always plug this back in to the original equation and see if it works. Okay, did you do that when you're in Algebra 1? Didn't they tell you to check a lot of times? Right, so you had 3x minus 5 equals 4. That was our original equation. So if you check, how do I check this? I'm not going to make you do this, but if you wanted to, you could. You put the 3 in for this, so it's 3 times 3 minus 5. That should equal 4, does it? 3 times 3 is 9 minus 5. Does 9 minus 5 equal 4? Of course it does, and then we have checked it. I'm not going to make you do that, but if you wanted to do that, you can feel free to do that. All right, I talked too much on that. Let's do the second example. Example 2. All right, so this one is not quite as easy as the first one, but eventually it will be. We just have to do a couple more steps. So let's see what we have. And we have some fractions in here. And I know nobody likes fractions. But let's see what we can do to get rid of some of these fractions. So equals 1/3, and then 2x minus 1. All right, let's switch to another color here. All right, so what we're going to do is we're going to look at this 1/2 and this 1/3, and we are going to try to get rid of those fractions right off the bat, just to make things a little bit easier for us. So the way we're going to do that is we're going to look at the 2 and the 3, the denominators, and we're going to find the least common multiple, or the common denominator. So if we find the least common multiple, that means 2 will divide into it, and 3 will divide into it. So what I'm going to do is I'm going to multiply both sides, okay, both sides by that least common multiple, and that way the 2 will cancel, the 3 will cancel, and then we'll have an equation without any fractions. So let's do that. First of all, we have to understand that we're going to multiply this whole entire left side by the least common multiple. So what I'm going to do is I'm going to put a parentheses around this whole entire thing. That's really important. Now, what would the least common multiple be with 2 and 3? Well, that would be 6. So I'm going to multiply both sides by 6. Now, right here, you don't really necessarily have to put a parentheses around this, because when I multiply this right side by a 6, since these two are being multiplied to each other, all I got to do is put a 6 right here and just multiply it by the 1/3. But this is a little different because these two are being multiplied, but you got this minus sign in between. So for instance, it would be something like this. Let's just go off to the side and then I'll erase this. So let me just think off the top of my head. So if I had like 2x minus 3, okay, and I had something like that. If I wanted to multiply this whole thing by, let's say that's 6, okay, so I would have to put that whole thing in parentheses and multiply it by 6. That way we're going to have to distribute. So that's what we're going to do eventually with this stuff up here. It's not those exact same numbers, but I just put in just random numbers just to show you. But if we had a situation like this, if I had like, I don't know, 2 times x, and I wanted to multiply this whole thing by, let's say, a 6 again, I don't have to multiply the 2 by a 6 and the x by a 6. All I have to do is multiply this by a 6, so all I would get was a 12x. All right, I don't know if that makes sense to you or not, but that's why we're not going to distribute a 6 through this, because I've got two things being multiplied. I got this thing and I've got this thing. Right here, I've got two things being multiplied, but I also have a minus in between. So I have to distribute that 6 through both of these things. I hope that makes some sense. So let's tell you what, let's do this. Let's go back to yellow. And let's go ahead and multiply this through. So I'm going to multiply this by a 6. So what happens here? 6 over 2 is 3. So I've got a 3, and then I've got an x plus 5. I'm teaching a math lesson. I'm recording it, so just so you know what I'm doing. Okay. I'm not just talking to myself. So anyway, I was talking to a couple guys that just walked in the door here. So I multiplied this by a 6, so 6 divided by 2 is 3. So I also have to multiply this by a 6 as well, because this is being distributed through this, and it's also being distributed through this. So 6 minus, or sorry, not 6 minus 4, it's 6 times negative 4, which is negative 24. So that's really important. That's the part right there that is really tricky about this. Now let's come over here and multiply this by 6. So the 3 and the 6, they'll cancel, makes a 2, or you could look at it as 6 divided by 3, which is a 2, and then 2x minus 1. So I don't have to multiply this by a 6 as well, because of that little number that I showed you earlier, that 6 times that 2x. So anyway, I hope that makes sense. I don't know if I explained it very well or not, but let's do the rest of this. Now it's pretty basic. That was the hard part right there, was just getting rid of the denominators. But now look, we don't have any fractions, so it makes it really easy. So what I'm going to do is distribute the 3 through this thing right here. And then we got a minus 24, don't forget about that. And then right here, distribute the 2, so I get a 4x minus 2. Let's add some like terms right here. So I've got 3x, and then this would be minus 9. And then I'm not going to do anything over here on the right side. There's nothing I can do over here. So now I'm in a situation where I can get the x's on the same side. So I would put the 3x over here on the right, just so that I can get that to be a positive x when I subtract. I could have put this over here. I could have put the 4x over here on the left-hand side, but then I would have gotten 3x minus 4x is negative 1x. Then I have to get rid of a negative. I'd just rather not have to do that. But you could do it either way, and it would work just fine. So now in the same step, I'm going to get rid of the 2, put it on the left-hand side. So I added 2 here, and I added 2 over here. So basically, I did 2 steps in one. So right here, they add up to 0. Negative 9 plus 2 is negative 7. Put your equal sign here. Yep. And then let's see. This adds up to 0. 4x minus 3x is just x, and that's your answer. X equals 7. So you could circle it like that, or you could just write it like this. That's probably looks a little bit nicer, and that's how we do that problem. Okay, on to the next one. We're going to skip example 3, and I'm going to go to example 4. So let's see if we can get this done. So again, this says to solve. And here it is. It's 2y plus 1. Again, here's something it's good that we did to review, because this first step, we did a lot of this stuff in that last review chapter we did. Do you see that? What do you think you're going to do to all this stuff right here first, before you start getting y by itself? You're going to do a FOIL method, exactly right. So let's do some FOIL on this. Ready? So first outside, inside, last. 2y times y is 2y squared. Outside is minus 2y. Inside is plus y. The last two terms is minus y. We just spent a whole chapter, well, not a whole chapter, but at least a section doing that kind of stuff. Let's do the same thing here. Let's distribute through here. FOIL method. Y times 2y is 2y squared. The outside is minus 5y. The inside is plus 10y. And the outside, or the last, I'm sorry, is minus 25. Let's simplify some stuff. So 2y squared, negative 2y plus 1y is negative y minus 1 equals, this is 2y squared. This is going to be a plus 5y, because negative 5y plus 10y is positive 5y minus 25. Now, this looks complicated because you got the y squared. But again, they rig these, okay? The author of the book rigged this so it comes out fairly easy. Look at the 2y squared and a 2y squared over here. What can we do with both of those? No? We could subtract them. 2y squared, watch this. Give me a second. So what happens? They cancel out, don't they? Okay? Now, let's get the y's on one side. So I'm going to add a y. I'm going to add a y. So that cancels out. Let's get the 25 on the left-hand side. So I'm going to add a 25. I'm going to add a 25. Okay? We're almost done. If I can change the color of this. There we go. Okay, let's see what happens. What's this going to be? 24. What's this going to be? 6y. That cancels out. Let's just make sure I did it right. I did. So divide both sides by 6. And y is what? 4. So I did that one right. So here's your homework. You're doing a 9 to 41 on section 1-1. Odds, of course. And that's pages 94 and 95. All right, so that's section 1-1, part 1. There it is.